Hey everybody, let's get ready for the Unit 3 test. Just got done with the band concert. A lot of fun there. Awesome job, 5th through 12th graders. So Unit 3, we've got a lot going on just with some decimals. That's a big part. We're rounding decimals, we're writing decimals, we're expanding, we're comparing. So right up here, I just added this little part. See the last page for place value chart? So just start at the place you're rounding to, then look to the right. If that number is 5 or more, the number you're rounding goes up. If the number to the right is 4 or less, then the number you're rounding stays the same. And then when rounding to the decimal, like we are in this, stop the number at the place you're rounding and include all the numbers in front of the number you're rounding. So we'll explain. Oh, oops. Okay, didn't know I could do that. We'll explain that, but let's start by looking at our place value chart. So just as a reminder here, I include this in the answer key, guys. You guys have this in class. It's on the back of the multiplication chart. Just remember, we got our decimal, then it's tenths, hundredths, thousandths behind it. And then in front of it, we have our ones spot, so 8 ones, 3 tens, no hundreds in this example, right? So if we just look at, if I start here with 38, 38 and 146 thousandths, right? So we're mainly focusing on the decimals behind the decimal point, but just as a reminder, every number has a place value, and this technically goes on forever in both directions. We only just have to go to the thousands in 5th grade. All right, so how does this work? Well, let's start by looking at this box here. Get my drawing tool. So again, first we're going to just write the number. So we should know that this is 4 37 hundredths. Again, we know it's 37 hundredths because it goes tenths, hundredths. Again, you can refer to that place value chart. This one here, there's no whole number, so it's 507 thousandths. Tenths, hundredths, thousandths. So we got 5 tens, no hundredths, but we do have 7 thousandths, okay? And then this last one is 2 and 349 thousandths. We have a whole number of 2, and then tenths, hundredths, thousandths. Again, each one of those numbers represents something specific with our place value chart. Now we also write the number name. Again, whatever words you say, those are the words you write. Just remember, and is where the decimal goes, and that's about it. Now the expanded form, we're just, again, relaying that to that place value chart. So if I have 4 ones, that's going to be 4 times 1, right? 3 tenths. That's 3 times 1 tenth. And then 7 hundredths, well, that's 7 times 1 hundredth. So notice the decimal is here, and then we get to our fraction parts, our decimal parts, okay? So again, on the next one, we don't have a whole number. There's 0, and notice they didn't write 0. You don't have to. You could say 0 and 507 thousandths if you want. I don't, but sometimes the book does. But we do have 5 tenths here. So 5 times 1 tenth. And they don't have any hundredths. Now, they could have put 0 times 1 hundredth. You could do that if you want. Don't have to. But we do have 7 thousandths. So it's going to be 7 times 1 thousandth. And again, this is just 507 thousandths. And then last but not least, 2 and 349 thousandths. Each one of these numbers represents something. This time we have 2 for a whole number, so we need to do 2 times 1. That's how we got that. Then we get to our decimal. And then we see we have 3 tenths, so it's going to be 3 times 1 tenth. We've got 4 hundredths, 4 times 1 hundredth. And finally, 9 thousandths. That's going to be 9 times 1 thousandth. So that's what everything represents. Number 2, less than, greater than, or equal to. We can see there's no equal to. And again, just like in class, I say, just like with your spelling words, ABC order, right? Alphabetical order. Now we're doing number order. Start at the very beginning and work until you get to something that's different. So if we look at this first example, well, we both had 3 for our ones, so that didn't matter. But we had a 0 and an 8, so I can stop there. Since 8 is more than 0, we know that this is larger. Also, if you look at the decimal, 3 and 87 thousandths versus 3 and 807 thousandths. 87 thousandths isn't very much, but 807 thousandths, You get, it's quite a bit. But really, just start at the beginning and go one number at a time until they're different. Let's see up next. We have no whole number, so that didn't help. But we have 1/10 versus 4/10. So right away, we can stop there because 4/10 is more. Now, some students like to have the same number of digits to the place. So if you want, you could put a 0 here. So you could think about 1600ths versus 4000ths. 40 would be more. But we don't have to have that because once we hit a different number, we're good to go. And then finally, we have 0 for our ones. I have a 1 for my 10th, okay? But then I have a 9 for my 100th and a 0 for my 100th. That 9 is larger. Or you could think about 190 thousandths versus 109 thousandths. 190 is going to be a little more than 109. But the key is start at the beginning, and the first time you get to one that isn't the same, whichever one is larger is the larger number. We don't even care about the rest of the numbers, really. Next, we have to put these numbers in order on our chart here, on our number line. So 0 down here, 1 whole here. In class, one thing we talked about too is, one thing we also talked about is I can cut this in half. So half would be right around maybe here. So we know that's 0.5. So if you were starting this, maybe putting where half is, just to help kind of line you up. If you want to take it one step farther, you could cut the half in half. So right around here would be about 0.25, and then right around here would be 0.75. Those are kind of extra. If you want to think about those, you can, but definitely start with the half mark. Let's see. There we go. By placing the half there, then we can kind of place what else we need. So first of all, we do need to make sure they're in number order. So the numbers they gave us all had 0 for a whole number because they're less than 1. But we had 2/10, 8/10, 0/10, and 4/10. So just based on the tenths, we know where these should kind of wind up. That 0/10 is going to be our smallest number here. And then we get 2/10, and that's going to be really close to 2500. So that's going to be roughly halfway. Again, I'm not getting my ruler out to check. As long as it's fairly close. We just don't want all these bunched up together if they're not really close. Because then we get to the 4/10. And again, that's getting close to 5/10. And then we kind of get a big gap here to 8/10. And it's really close to 9/10 as well. So again, understanding, where these numbers wind up. And as long as it's approximately close, you're good to go. Now we get to the rounding part that I talked a little bit about at the beginning. So whatever place you're rounding to, we're going to start there and then look to the right, look behind it, and see what number's there. If the number behind it is 5 or more, then our number's going to round up. And we can talk about why that is as well. So this is to the nearest 1. So we're going to start at the 4. Go next door, I see a 9. Well, what's 9 going to tell us? Well, 9 is 5 or more. It's more than 5. So that 4 is going to go up to 5. And then we just write it as 5. Now, real quick, why is that? Anytime we're rounding, we can really think about a number line. In this case, we have number 4.946, but we'll just say 4.9. So if we were to draw a number line, we know it's going to be somewhere between 4 and 5, right? So 4.9 is right here. This is 4. This is 5. Well, if I have 4.9, we can say 4.6 if we want to make it official here. We're rounding to the nearest whole number, so we start that whole number. Look behind it, we see a 9. That tells us it's closer to 5. Can we also clearly see that on this number line? Yeah. So, just remember, what we're doing is really based on the number line. If we're rounding to the nearest 1, the nearest whole number is going to be closer to 4 or 5. Well, it's really close to 5. Actually, I should have put it a little closer, really, but exactly. To the nearest 10th. Again, what do I have in my 10th place? A 9. What do I see behind it? I see a 4. Nope. So that 9 is going to stay the same. So I just write 4.9. We end there. If it was 5 or more, that would actually round to 5 again. We talked in class a little bit about that, but don't have to worry about that in this case. So the nearest 100th, I see a 4. Go behind it, we see a 6. 6 is 5 or more, so this is going to turn into a 5 because it's closer to 5. And again, if I'm rounding to the 100th, I just end at the 100th, and we're done. Okay, guys, so that's all we're doing is start the number we're rounding to. Again, we started at 3. What's behind the 3 is 0, so that's clearly closer to 3 than it would be 4. Nearest 10th, we see a 0. What's behind the 0? 5. So 5 or more, because the rule is, you know what, if it's halfway, if it's 5, we're just going to round up. So that's why it goes to 1. And then the nearest 100th, we see a 5. Behind it, we see a 3. No, he's 4 or less, so that 5 is going to stay the same. It's going to be 3 and 5 hundredths. Okay. Up next, we have to just answer a couple of these. One strategy is just stack your numbers, right? 4.62 plus 2.99. 9 plus 2 is 11. 9 plus 1 is 10. Plus 6 is 16. 4, 5, 6, 7. Good old 6, 7. Another way it says you could also do the give and take strategy. We talked about this in class. 4 and 62 hundredths, and then 2.99. We could also think about this a little differently. We could add 1/100th to this 299 and make it 3.00, just make it a 3. But if I add 1 to here, we got to take away 1 from this one. And we are talking about 1/100th, by the way. So if I add 1/100th, we got to take away 1/100th. So that'd be 4.61. And they're just saying you can do that so you don't have to do as much carrying and regrouping. 6, 1, and the 7. It doesn't really matter. If you are comfortable with that, cool. If not, just just stack them and add them. And then with our division or our subtraction here, again, line up those decimals. 7 and 89 hundredths minus 3 and 2 tenths. Just remember, we can always put a 0 if there's not a number there. Placeholder 0. Either way, 9 minus 0 is just 9. 8 minus 2 is 6. 7 minus 3 is 4. Okay? So just regroup as you need. And number 6 is the same idea, guys. Just adding, regrouping, carrying. Doesn't look to be anything too tricky on these. 5 plus, we get 8, 9. 9 plus 4 is 13. 8 plus 4 is 12. So we should, if you're on your homework, I should see you carrying it over. 9 plus 1 is 10. Plus 3 is 13. And then 4, 5, 6, 7 again. Okay? Now we're subtracting. 1 minus 0 is 1. 0 minus 4, we can't do that. So we are going to have to regroup on this, make that a 4, and make this a 10. 10 minus 4 is 6, and then 4 minus 2 is 2. Again, the biggest thing is just line up those decimals. 3 minus 0 is 3. 8 minus 9, can't do that. So we're going to regroup over here, make that 18. 18 minus 9 is 9, and we're good to go. Okay. Number 7. The football stadium in our town holds thousands of people. It's Kids Day, and they're only charging $2.40 per admission. So we just got a chart to fill out. So if one person goes, it's $2.40 because it's $2.40 for each ticket. If 10 people go, what happens if we multiply by 10? Essentially, we're just going to start moving that decimal, right? So $2.40 times 10 means we just move it one time. So it'd be $24. Again, if we're multiplying this by 100, so for here, we're just kind of multiplying by 10. So we got to multiply that by 10, right? Up next, we multiply by 100. So we're going to multiply this by 100. If we multiply by 100, we move it twice. So 1, 2. So now it's behind the 0 there. Do a little more accurate. 1, 2. It's right here. So that's how we get $2.40. Okay. And then next we're multiplying by 1,000. So guess what? We're multiplying both numbers by 1,000. And again, there's 3 zeros, so we got to move it 3 times. So 1, 2, 3. Now we did need to put a 0 placeholder in there. So it'll be 2400. 2400. And yes, technically there's a comma for to show the thousands, but yep, 2400. And I don't really care if you have the 0.00. There's no change on these. And then finally, we got to multiply by 10,000. Well, however many zeros there are, that's how many times we're moving our decimal. Since there are 4 zeros, we're moving it 4 times. Right? So 1, 2, 3, 4. So I got to put 2 placeholder zeros, 24000. And it turns out to be, yep, 24,000. So again, however many zeros we're multiplying by, that's just how many times we moved the decimal. Without the decimal, we think about just placing zeros at the end, but you're still just also moving the decimal. Now, these answers to B and C are kind of similar. So what happens to the number of zeros in the product as you multiply a number by 10, then by 10 again, then by 10 again? And why? So basically, the number of zeros increases as the decimal moves to the right. For each power of 10, the number increases by 10 times the value. So its digits shift by place value. Basically, again, just we're going to move the decimal however many zeros we're multiplying by that power of 10. When John was looking at the table, he noticed when you multiply a number by 10 again, by 10 again, the decimal point moves over to the right one place every time. Explain why this works. Again, for each power of 10, the number increases 10 times the value. The digits shift to the place. Here's the deal. You can basically put the same answers for these two guys. I'm not worried about it. As long as you understand, for every power of 10, you move the decimal over one more time. So that's what we're thinking about there. Next, we get into our metric conversions. So it tells us 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. So A and B, we're dealing with kilometers and meters. So again, 1 kilometer is 1,000 meters. So basically, we just set up our little chart and just kind of go from there. So if I have 1 kilometer, I multiply by 1,000 to get how many meters there are. Or if I have the meters, I got to divide by that to get the kilometer. And by the way, meter, I got a couple of yardsticks here. These are the yardsticks. A yard is 3 feet, so this has 36 inches. A meter is, I think, 39.37 inches, so basically 40 inches. So a meter stick is just a little less than 4 inches longer than one of these. So they're pretty similar, but just as reference, that yardstick is pretty darn close to a meter stick. So meter is just a little bit longer, about 4 inches. Anyhow, so let's set up our chart and fill in what we need to find. So our first example, how many meters is 34 kilometers? Well, if I set up my chart, so 34 kilometers, now we got to find out how many meters. Well, what's our rule? If I know the kilometers, I got to multiply by 1,000 to get my meters. So if I started with 34, if I multiply by 1,000, that's 3 zeros. We just went over on that chart above. So right here, so go 1, 2, 3. And in this case, we can also just think, add 3 zeros, right? Cool. So that's going to be 34,000 meters. And then for B, how many kilometers is 34 meters? Well, if I say 34 meters, what do I have to do to go from meters to kilometers? I got to divide by 1,000. So since 1,000 has 3 zeros, we're still going to move the decimal 3 times, 3 places, but now it's going to get smaller. Now it's going to move to the left. So if I start with my 34 meters, right, here's my decimal, right? Now I'm getting smaller, so now I got to move it 3 places the other way. 1, 2, 3. My decimal is going to be right here. So I got to put my 0 placeholder, and you can say 0 for my 1's digit as well, so 0.034. That's how we get that. Okay? Now, for C and D, we're talking about meters and centimeters. So 1 meter is 100 centimeters. So look at our chart. 1 meter is 100 centimeters. So if I know my meters, I just multiply by 100 to get centimeters. Or if I know how many centimeters, I got to divide by 100 to see how many meters. And that should make sense, guys, okay? Again, a meter stick 1 meter is roughly this long. It's a little bit longer than this, but that's about this long. So I can have 1 meter, or that would be 100 centimeters. So obviously centimeters are a lot smaller. So that's why the numbers, are going to be changing like they are. So let's set up our chart here. How many centimeters is 5.1 meters? Well, let's see. So if I put 5.1 on my meters side, what do I do to go from this side to here? Oh, I got to multiply by 100. So 100's got 2 zeros. We're just going to move that decimal twice. So 5.1, go 1, 2. Now it's here. Place my 0. Ooh, 510. And then how many meters is 340 centimeters? Well, if we have 340 centimeters, we got to figure out how many meters. What do we got to do? Now we got to divide by 100. So we started at 340, it said. So my decimal's right here. But divided by 100, it's going to get smaller. So 1, 2, it's going to wind up right here. That's how we get 3.40. 3 and 40 hundredths meters. Yes, you could just say 3.4. You don't have to have the 0, but they're kind of just keeping it there just to keep it consistent. All right, rest of this might look like a lot. There's only 2 more questions, guys, really. Number 9 is choose one of these to do. So there's 4 different division problems. There's no remainders. First, it says just come up with a story problem. Have some fun. The example, in Marysville, 12 city blocks equals 1 mile. The race this Saturday is 156 city blocks. How many miles is that? Okay. Something a little more simpler might be, there was 12 kids. They made a total of 156 cookies. How many cookies did each kid get? But either way, we can see if we take that first example, we just need to do 156 divided by 12. Now, down here, they give you the grid paper. If you want to kind of use the area model we've talked about, where we know we're dividing by 12. So if I go down 12, how far over do I have to get so I have 156? So if you want to use that, you can, or just do the good old partial quotient division. Pretty similar to long division, like, old people like me grew up with. So we got to see, how many times is 12 going to 156? Can I do 10 groups? What's 10 times 12? 120. Oh, yeah, we can do that. So 10 times 12 is 120. So 6 minus 0 is 6. 5 minus 2 is 3. And then those cancel out. How many times is 12 going to 36? 3 times. And yeah, we can see there is no remainder because we got 0 down here. So what's 10 plus 3? It is 13. And we can also see, you see how we chunked it up into 10 and 3? Really, that's what this is showing down here. If I go 12, wow, if I can draw straight. If I go down 12 and over 10, what's 12 times 10? Hey, that was that 120 we talked about. And then I had to go over, so I went over 10. And then we went over 3 more. What's 3 times 12? That's that 36. So that's really where the chunks come from. That's why we say start with 10 if you can. And that works nicely with our grid paper. And together, what's 120 plus 36? It is that 156. So if you want to use that, you can. You don't even have to use it. It says you don't even have to. So this whole page is just one question, basically. Pick the one you want to do. Write me a story problem and solve it. And last page, again, it's just one problem. We got the 5th graders are going on an overnight camping trip, and all we have 140 kids and adults. They're traveling to the camp in the passenger vans. If each van can carry 12 passengers, how many vans will they need to get everyone there at the same time? This will be a remainder. We've talked about these before in the first unit. Again, what is our expression? 140 divided by 12. Again, if you want, just do good old division, how we've been doing it. We call it partial quotient. How many times is 12 going to 140? Well, I can do 10 times 12. That's 120. 0. 2. right? And then how many times is 12 going to 20? Well, 12 only goes to 20 one time. So 1 times 12 is 12. We subtract, and we get 2 left over. Nope, 8. 12 minus 2 is 8. Hey, it's a long night. It's 9:30. I was at a band concert. Sorry, I saw that too. So 10 minus 2 is 8. So there's no more groups of 12. So what's our whole number going to be? It's going to be 12, and then remainder 8. Now, I don't really like saying remainder 8. I mean, it's fine in this case. Really, it's going to be 12 and 8 twelfths in this case. So we say 12 remainder 8 or 12 and 8 twelfths. That means we've got 12 buses and we got 8 more seats that we need to fill. Now, we can't take a part of a bus. Oh, I'm sorry. Again, getting late. Sorry about that. Hold up. It is 11. 10 plus 1 is 11. So 11 and then 8 twelfths. So we got remainder 8 or 8 out of the 12. So we've got 11 buses and we got 8 more seats we got to fill. So we could say 11 remainder 8 buses. You can't take part of a bus, so that's why the actual answer is going to be 12. Because technically we had 11 and 8 twelfths, but we can't take part of a van. We're not cutting it up, so we got to have 12 vans. And then you can see on the answer key, we could set up kind of an area model here. Another thing with this example specifically, you might say, hey, you know what, 12 times 12, that's 144. So, yeah, we're going to need 12 vans because I know that that's only 4 extra. So, again, whatever you want to come up with, as long as you can justify your answer, you are good to go. Again, guys, thanks for rocking this unit. And, this will get us through our Christmas vacation. So, have a great one, guys. Let me know if you have any questions.